Since we are done deriving the laws of radicals, now we are ready to simplify radicals. And that is what you're going to witness in this video. So this is Aguila, and welcome again to Agimath. Simplifying radicals. A radical expression is in simplest form if we can meet the following specifications. First, all perfect nth powers have been removed from the radicand. So meaning, inside a radical sign, there will be no perfect powers, and it will depend on what is our index. Second, the index and the exponents of the factors in the radicand have no common factor other than 1. So for the second one, we are going to look at the exponents of the factors and the index if they have no common factor. If they have common factor, then we cannot call it a radical form in simplest form. Number 3, no fractions are present in the radicand. In simplifying radicals, we can do the following. First, removal of perfect nth powers from the radicand. So you will understand more about this when I will be giving you examples. Second, reduction of the index of the radical. And third, rationalization of the denominator in the radicand. So rationalization is a new term. So later on, we are going to define what is rationalization. So we are going to recall the laws of radicals that we have derived in the previous video. First one, we have the nth root of a to the power of n that is equal to a. So notice that if our radicand has an exponent equal to the index, they will just cancel with each other and then the remaining is a. Second, the nth root of ab is equal to the nth root of a times the nth root of b, or vice versa. Meaning if we have the nth root of the product, we can separate them into its factors. So the nth root of a and the nth root of b. So that's for multiplication. For number 3, it's for division. So the quotient, given that b is not equal to 0 because that will make our fraction undefined. And then for number 4, observe that in our radicand and in our index, we have a common factor, which is k. So to simplify problems like that, we just cancel out what is common. So notice that the k, which is common for the exponent and the index, is gone on the right side because it is being cancelled out. Okay, let's have our first example. Simplify the square root of 45. So the technique in simplifying radicals, you need to know what is our index because that is very important. So in this case, because we cannot say any number on this position where the index is located, it is understood that our index is 2. So simplify the square root of 45. But 45 is not a perfect square. That's why we need to simplify. So how are we going to simplify? If the problem is just like this, we are just going to factor 45 such that one of its factor is a perfect square. Now, if you are familiar with perfect square and you know factoring, it will automatically give you these factors. 45 is equal to 9 times 5. Again, why did we factor 45 in this way? Because we want that one of the factor is a perfect square. And the perfect square, because there could be a case wherein there is another perfect square, you choose the highest. So after that, we can apply the laws of radicals wherein we are going to separate the factors which are 9 and 5. So we can have the square root of 9 and the square root of 5. Basically, I'm just showing to you how you are going to do it step by step. Now, what's the square root of 9? Square root of 9 is 3. And since 5 is not a perfect square, so we just copy square root of 5. And that's it. Magic rectangle. Now you will know if you already found the final answer because inside your radical sign, it is already simplified, meaning if it's a number, then it cannot be factored anymore in such a way that one of the factor is a perfect square. Next, second example. Simplify the cube root of 24. Now, the difference between example 1 and example 2. For example 1, the index is 2, but for example 2, the index is 3. Now, the same process. We need to factor 24 such that one of the factor is a perfect cube. This time, it should be a perfect cube because our index is 3. Now, you need to memorize the perfect cubes to make it easier. Now, I just factored 24 into 8 times 3 because 8 is a perfect cube. Why? Because 2 times 2 times 2 is equal to 8. Meaning, 8 is a perfect cube. And then, the same with the previous example, we are going to apply the laws on radicals wherein we are going to separate the factors and then next extract the cube root. Again, the cube root of 8 is 2, and since this cannot be simplified anymore, we just copy. So you have 2, the cube root of 3. And that's it, magic rectangle. So again, for examples like this, you should be expert on factoring as well as memorize a little perfect squares and perfect cubes that will be handy for you as students. Third example. Simplify the square root of 18 x to the power of 5 y to the power of 3. Okay, on the third example, I included a variable because when there are variables, it is easier. Sure. So first thing we are going to do, we concentrate with the number 18. And then observe that our index is 2, so we should be looking for perfect square. And what is the factor of 18, which is a perfect square? Okay, very good. It's 9 times 2. 9 is a perfect square. Now, after dealing with the number, we go to the variable. First one is x to the power of 5. Now, to factor this one such that one of the factors is a perfect square, just look at the index. Index is 2. So again, 5 is not divisible by 2. But what is the highest number but less than 5 which is divisible by 2? Highest number but less than 5 that is divisible by 2. That is 4, right? So we factor x to the power of 5 into x to the power of 4 times x to the power of 1, or simply x. So again, if you are going to ask why it's x to the power of 4 times x, we just need to factor x to the power of 5 such that one of the factor is a perfect square because our index is 2. And to do that, the exponent should be divisible by 2. Divisible by 2. And then, to check if this is the correct factor, 4 plus 1, applying the product rule, that will result to 5. So that is x to the power of 5. When it comes to y, the same process. Since the index is 2, you ask yourselves what is the highest number which is divisible by 2 but less than 3. So you only have one choice, which is 2. So we factor y cubed into y squared times y. Again, 2 is divisible by 2, and then 2 plus 1 is 3. So we have y cubed. After that, we group together those that are perfect squares. 9, x to the power of 4, and y squared. When it comes to number, you should memorize. When it comes to variable, again, just remember that the exponent should be divisible by the index, and that is a perfect power. So for example, if the index is 3, the exponents on x and y should be divisible by 3 so that it will become a perfect power. Now we group them together. 9 times x to the power of 4 times y squared. And then on the other radical sign, the remaining, we have 2x and y. Now we simplify. What is the square root of 9? Square root of 9 is 3. When it comes to variable, what you're going to do is very simple. We copy the base, which is x, and then you look at the exponent, you divide it by the index. So 4 divided by 2 is equal to 2. And when it comes to y squared, 2 divided by 2 is 1. But we don't need to write 1. That's why we have 3x squared y. And then just copy the remaining because we already know this cannot be simplified. And that's it. Magic rectangle. Let's move to the fourth example. Simplify the 6th root of x to the power of 9. Now observe that the exponent on the radicand is greater than the exponent on the index, meaning it is really not simplified because we can only say that a radical expression is simplified if the exponent inside the radical sign, all the exponents inside the radical sign are less than the index. But in this case, it is greater than. So to simplify problems like this, we are just going to, again, to factor. X to the power of 9, we factor that such that one of the factor is containing the index, which is 6, or if this exponent is greater than 12, we use 12, which is divisible by the index 6. But in this case, because this is just 9, we factor such that the exponent of the x should be equal to the index. So that's the pattern. The exponent of the variable should be equal to the index. And then the remaining, x cubed, because 6 plus 3 is equal to 9. Next is we apply the laws on radicals. We separate the factors so that we can simplify. The 6th root of x to the power of 6, as I presented in the laws of radicals, the variable has an exponent 6, which is equal to the index. So automatically, it will cancel with each other. That's why we have x. And then just copy the remaining. And then you look at the remaining radical expression. X to the power of 3, and then the index is 6. You focus on the exponent and the index, 3 and 6. What can you say about 3 and 6? They are all divisible by 3, meaning we still need to reduce the exponent and the index. And to do that, just look for the GCF, the greatest common factor. So GCF is 3. So 6 divided by 3 is equal to 2. So instead of an index 6, it is being reduced to 2 because they have a common factor. And then 3 divided by 3 is 1. So we have x to the power of 1, or simply x. And since the index is 2, we can just, we don't need to write 2. So final answer, we have x times the square root of x. Sample 5, the 6th root of 4. So in this case, if you look at the exponent of 4, it is 1. And then the index is 6. And you might say, sir, it's already simplified. Come on, child. The world is very deceiving. When you look at 4, or if you always do this, automatically you will say that 4 is a perfect square. That is 2 squared. That's why we can write 4 as 2 squared. So this time, you look at the exponent and the index. Exponent is 2, the index is 6. What can you say about 2 and 6? They are both divisible by 2. So meaning we can still reduce the exponent and the index by just dividing them by the GCF, which is 2. So 6 divided by 2 is equal to 3. So we can write the index 3. And then 2 divided by 2 is 1. So that is 2 to the power of 1, or simply 2. And that's it. Magic rectangle. Example 6. Simplify 8 over the square root of 2. So in this problem, you can see that in the denominator, it contains a radical sign. So that's making the radical expression not simplified, because a radical expression is simplified if it does not contain a radical sign in the denominator. And to simplify problems like this, we need to have this process. It's called rationalization, the process of simplifying radical in the denominator or a fraction in the radicand. To rationalize, multiply the numerator and the denominator by an expression of lowest power that will make the denominator of a perfect nth power. We need to multiply something just to make the denominator a perfect power. So, to determine how to make it a perfect power, just look at the index. So, let's have our example. 8 over square root of 2. Our problem is this one. Our denominator contains a radical sign. And if you look at the radicand, it's 2. Index is 2. So meaning if the index is 2, we're looking for a perfect square. So how are we going to make 2 into a perfect square? Yes, we are going to multiply 2 by 2. Because 2 times 2 is 4, and 4 is a perfect square. That's why we multiply this expression by square root of 2 over square root of 2. Again, our basis is the denominator. Just make it a perfect square. Now, if you can find that number to multiply the given to make it a perfect square, just copy in the numerator. And then, you might be asking, sir, are we not changing the problem when we multiply something to it? The answer is, we are not. Because if you're going to look at this carefully, square root of 2 times square root of 2, square root of 2 over square root of 2 is just equal to 1. So basically, what we are just doing is just multiplying the expression by 1. And any number multiplied by 1 is just the same number. So we are not changing the problem, and that's it. So after finding the correct multiplier, we call this multiplier, we can now simplify. So meaning multiply 8 times square root of 2. We cannot multiply 8 and 2 because 2 is inside the radical sign. So just put them side by side. So you have 8 square root of 2, but in the denominator, since they are the same, they are on a radical sign, on a square root, the same index, we can multiply. So again, since we are not yet done with operations on radicals, just remember we can multiply as long as they have the same index. Indices are the same, 2. So we can multiply 2 times 2, that is square root of 4. But what is square root of 4? That is equal to 2. And then, remember that 8 is a whole number, 2 is also a whole number. They are not inside the radical sign, so we can divide. 8 divided by 2 is equal to 4. And that's why we will have 4 square root of 2. And that's it. Magic rectangle. Example 7. Simplify the square root of 5 over 4a raised to the power of 5. So in this problem, this radical expression is not yet simplified, because if you are going to look at it, the radical sign contains a fraction and that is not allowed. So if the problem is like that, the only solution is to do rationalization. To do rationalization, just focus on the denominator. How you are going to make it a perfect square. Now, when we look at the denominator, it's 4. Index is 2. So meaning we are going to look for perfect square. But 4 is already a perfect square. So we don't need to multiply something to 4. But how about a to the power of 5? The exponent is 5. The index is 2. 5 is not divisible by 2. That's why, what are we going to multiply to make a to the power of 5 divisible by 2? We multiply it by a. We multiply it by a, the square root of a. Why? Because a to the power of 5 times a, that is applying the product rule. We just add the exponent. Exponent is 5. Exponent is 1. 5 plus 1 is 6. And 6 is divisible by 2. That's why we need to multiply by the square root of a. And then what we write in here, we just copy square root of a. Again, that is just equal to 1, so we are not changing the problem. Next is to simplify further. This time, 5 and a are both inside the radical sign, and the indices are equal. Meaning, we can multiply 5 and a. 5 times a is 5a. That's why we can have 5a, the square root of 5a. And then, on the denominator, we can also multiply because we have indices are equal. So 4a to the power of 5 times a, that is equal to 4a to the power of 6. And then, expect that in the denominator, there should be no radical sign because we are doing rationalization. So we need to simplify further the square root of 5a. And then, what's the square root of 4? Square root of 4 is equal to 2. And then for a to the power of 6, just copy a. And then 6 divided by 2 is equal to 3. And that's it. Magic rectangle. Last example. The most difficult example. Simplify square root of 9 over square root of 3. So before you are going to rationalize, you analyze first. Square root of 9 over square root of 3. In this case, we don't need to rationalize. Why? Because we can divide 9 by 3. So 9 divided by 3 is equal to 3. And we have square root of 3, and that's it. Thank you for watching. And do not forget to hit the like button, and then can you give me a hello on the comment section? Thank you.